頭赤 IT 編集長のMikiです。今日はプラットフォームコンピューティングの CEO ソニアン・ゾウさん、をお迎えしまして、理想的な、企業におけるクラウドコンピューティング環境とは何かと、そしてそのプラットフォームコンピューティングさんはどういうことができるのかということをお伺いしたいと思います。よろしくお願いします。
Thank you very much. That's a great question. From our perspective, from the commodity clusters to grid computing to run a lot of applications in the enterprise to now cloud, it's a very natural evolution of distributed computing systems and infrastructure to help the organizations and enterprises to share increasingly scale of resources and run all kinds of applications. And it's our natural evolution. Therefore, the products and technology we have can be easily evolved and applied to more and more applications and manage and use more and more dynamic infrastructure to help our customers to keep going forward. It's a natural evolution. Clusters to grid computing to cloud now.
Right.
Yeah, I think the virtualization is a key enabling technology and component for running a private cloud environment. But that's not sufficient. It's necessary. A private cloud is an operating environment integrating various computing resources, the servers, the storage, and interconnects, to run applications for the users in a dynamic, on-demand basis. And customers and users can run applications through self-services. And that requires them to share these resources among the applications. And as a result, there are fundamental new technologies to be introduced on top of VMs, on top of existing operating systems and storages to deliver these cloud experiences, and specific for private cloud for the medium to large organizations and enterprises to still conform to their security, compliance, and application environments they need to run their business on. So there are fundamental things. And from our experiences in the enterprise data center environment, the only areas people have been sharing scalable resources to run a variety of applications has been the HPC or grid environments, right? And therefore, the sharing model of the grid and clusters should be integrated and combined with the VM technology, integrated with applications and middleware to deliver a private cloud experience. In a grid environment, you are running a bunch of typically computing or data-intensive applications against a set of resources. But the workload is dynamic and shared, and resources, on the other hand, is typically static. So you can have a bunch of Linux machines and Windows machines, and then you are trying to make the best use of these resources to run the jobs you need to run. But there could be cases where you have a lot of Windows jobs, and all the Windows servers are busy, used. But then you have Linux machines idle because you happen to not have Linux required application to run. So that's a grid situation. Cloud goes one step forward from grid to dynamically provision the resources. And it can bare metal provision industry sense server from Linux to Windows. It can also leverage VMs, like VMware hypervisors, to dynamically set up guest OSs with a version and an application library environments as needed by the application that need to run at this point. That's why the cloud is on-demand and dynamic. So that's a step forward from the grid, even though both are shared environment used by organizations. Another big difference is that cloud specifically enables the use of external resources in the service providers to go beyond enterprise data center space. And the last difference, I think the most important difference, is that cloud applies much more general to all kinds of applications, because it's specifically focused on managing and sharing resources and provision resources dynamically to run whatever applications. So it's more application independent. No longer HPC applications typically used in a grid environment. No longer computing or data intensive applications. Could be Java applications. Could be all kind of web services or enterprise batch overnight. In some sense, our product does things similar to Amazon does, except the model is very different. We are not a service company providing computing resources service as Amazon does in the EC2. Instead, we provide packaged management software products for enterprises or for service providers to install and configure, build their cloud, and implement the Amazon type of experience. Second is that because we target enterprise market, we enable them to have a much more extensive integrated environment to run the applications to their liking. That's why it's called private cloud, meaning they can configure to use their own hypervisors. They can configure to use their existing security framework. They can support their own IT approval processes and have their own report and billing, whereas we provide all the resource consumption data of the applications. We also allow them to use internal resources as well as external resources. So our products help the enterprises to implement cloud computing experiences using external or internal resources in a very flexible way to support very heterogeneous environment and all kinds of applications. So you are hitting a key point about the cloud and our product capability, orchestration. Orchestration has several senses. One is to orchestrate the resources to dynamically set them up to meet the user and applications requirements. But also more importantly, orchestration in the sense of understanding applications, the service levels required by the applications, so that you can dynamically, intelligently allocate the resources to run the applications to meet the service level, yet still ensure high utilization, right? To ensure the heterogeneous resources are used effectively and deliver the service level at low cost. So the orchestration is a key intelligent scheduling policy aspect of cloud computing management software. Yeah, I think you're pointing out about probably the most important aspect about adopting cloud computing. It's not about technologies. It's about first applications and about how to evolve the way you run these applications and run your data centers in a way that's evolutionary. Multiple steps of evolution rather than disruptive revolutions, which is typically not productive and high risk for the enterprise. So as a result, from platform computing point of view, with 18 years of experience working with enterprise, we have engineered the products such that it can help and make it easy for users to adopt this general approach of clusters, grids, and clouds in a step-by-step way. For example, you can deploy your new applications or migrate your existing application from some big Unix SMP servers to a commodity cluster. Still running in isolation is a cluster server rather than a big SMP Unix server. It dramatically reduces the cost because the Intel AMD chip-based servers from HP or NEC or Dell is so much cheaper, right? So that's the first step, right? But once you've done that, you may find that you have a number of these clusters running individual applications. Again, you are in a siloed environment. Lower cost silo, but still silo. Utilization may still be 10, 20%, very low. But then next step is you can combine these clusters together to form what we call enterprise